Hello class, this is a first part of the lecture on chapter 11, and so the first part is really going to just cover a very important concept we're using in both financial and managerial accounting as well as in any finance course called time value of money, TVM. So I will just cover this overview of the time value of money concept. If you're familiar with it from your financial accounting course, then you can go ahead and just watch the second half of the second part of the video for chapter 11, which will cover the actual capital budgeting process. I will just talk about TVM right now, time value of money. So the concept here talks about the idea that invested money, because of the interest rate, earns income over time. So we would always prefer to receive cash sooner than later, because cash today is worth more than the same amount will be worth in the future due to inflation, right? So this is some of the definitions I would like you to be familiar with. Compounding, that's I will show it to you. I'll talk more about it in the next two slides. Discounting. So compounding is going from the present to the future. Discounting is when you know the future value or you have some idea of what you need to get from your investment and you're going backwards. So discounting is going from the future to the present. So concepts of present value today, future value, future, and annuity. And we will be using tables in your textbook. They are at the end of the book on pages B10, B11. It's Appendix B at the end of the book. So for the purpose of this chapter, we only will be using two tables. Let me show you those. So I went to your textbook. This is page B10. We only will be using table B1, which is PV of $1, present value $1. And we will be using table B3, present value of an annuity of $1. We will not be using future value tables. I will come back to them. Okay, so to calculate time value of money, you can use Excel, financial calculators, or online calculator, or the tables, right? I will show you one of the online calculators. If you have a financial calculator, you can use it. If you're using Excel, that's fine. Just be aware that if you're using Excel versus the textbook tables, the answers will be a little bit different, a few dollars different because of rounding up and also how the factors are presented. Your Connect assignments will accept a certain margin of error, so usually a certain small percentage plus or minus will be fine depending on whatever original source you're using. Okay, so simple interest. This is simple interest, right? I invest $10,000 and I earn interest only on the principal, not on the additional interest. So let's say I am investing $10,000 and I'm earning 6%. So every year I earn $600. So after 5 years, my total interest earned is $3,000. A compound interest concept is very different, and that's what we will be using here. We're earning interest on principal plus all the interest earned to date. So look right here. Should say to date right here. So in year one, my principal is 10,000, 6%. I earn $600. But I keep this $600, and the second year I'm earning interest of the same 6%, but on principal plus interest. So the second year interest goes up to 636. Third year to 674 because my base increases. And so as a result, after 5 years, instead of earning 3,000, that is the amount of interest we earned using simple interest, we would have earned $3,383 or $383 extra interest from compounding. It doesn't look like it's that much bigger, but right here I have a slide where I said, well, you invest $10,000 for 40 years at 12%, 40 years. So if you look at the simple interest, After 40 years, at the end, I will have $58,000. Looks good. It grew up almost 6 times. Simple interest. But look at the beauty of compounding. If I invested $10,000 and I earned the same 12%, at the end of year 40, I will have $930,510. That's a huge amount. It's just the intense power of compounding. That's why we always say start investing when you're young. The younger you start investing, the power of compounding will just multiply your original investment. Okay, present value is always less than future value because of inflation. Present value is the amount that we have to invest now at a given rate of interest. So the rate will always given to you, and it's the average market rate right now in certain investment instruments to produce a given future value. The future value is the amount that your investment will be worth at a future date if it's invested at a given rate of a compound interest. Annuity is a series of equal payments or receipts, right? So any kind of, most of the pensions, if you think about the pension, that's an annuity, right? It's the same amount that we receive every month. If you think about your mortgage payment or your auto loan payment, it's an annuity where we are making equal payments, right? We're making an equal payment, and the lending institution, like a bank, is receiving an equal payment every month. They receive the same fixed payment from you, and that's called an annuity. So here are some examples for practice, right? So I need to get $200,000 10 years from now. So the question, first of all, what do I know? And what am I looking for? I know future value, right? So I'm going to be discounting. My future value is $200,000. My present value is a question mark. You always have to have N for periods. Right here, 10 years from now, that's the number of periods. A, interest rate you could earn is 8%, right? So I'm going to go to the tables. Present value of $1. There's no annuity, it's just lump sum. I need to get a lump sum 10 years from now. So how much should I invest today? So if I look up in the table, we look at the rate. The rate is 8% right here, the column, and the number of periods. Here it's number of years, but I want you to think of the number of periods because here we will be compounding once a year. So 10 periods. This is my present value of a dollar factor. What it means is that if I invest 46 cents today, it will grow in 10 years to be $1. But I want it to grow to be $200,000. So I take this present value of annuity factor, 0.4632, multiply by the future value. This is how much I should invest today. If I invest today $92,640, at this rate, 8% for 10 years compounded annually, it will grow to be $200,000. Let me show you the same data if I'm using one of these financial calculators online. There are plenty of them. So I know the future value. I want to have $200,000. My annual rate is 8%, compounding annually. Periods, 10 periods. What do I want to know? Present value. Look at this, 92,639. If you look at our answer, 92,640. So it's a little bit more than $1 off, but that's fine. It's just because of rounding up. I also want you to notice right here, if you see future value is positive, present value is negative, it's always going to be this way. Or if present value is, if I put future value as negative, then my present value would be positive because one of them is the cash outflow and another one is inflow. Like if I invest today, which would be negative to me, $92,638, then in the future I receive a positive of $200,000 or vice versa. Okay, what if I change this and I only say everything is the same, but what if my interest is compounded every quarter, right? So instead of 10 periods, I will have 40 periods. And instead of 8%, it would be 2%. So I can either do the table or I can do the calculation right here. So I will now have annual rate 2%, 8% divided by 4 quarters. So every quarter it's 2%. And the periods is now 40%. It's 10 years, but we get paid interest every quarter. So if I want to know present value now, it would be less, 90,578. If I use the table from your book, it's 90,580, right? The difference is just a couple of bucks, which is insignificant. So look at the red amounts. If it's compounded more often, initially I have to invest less money, right? 2,000 less to get the same future value, right? When your interest goes up or the number of periods goes up, your present value will go down because you need to invest less money from the beginning today. This is an example of an annuity. I want to receive $100,000 for each of the 5 years. Like, how much money should I put in the investment today so I can get a flow of 100K every year for 5 years, right? If my interest rate is 4%, how much do I invest today? So I want the annuity for 5 years. Let me go to the tables. By the way, if you use this calculator or a financial calculator, annuity is abbreviated as payments. That's annuity. But I want to use the table B3, present value of annuity. I already forgot the facts. So it's 4%, 5 years. 4%, 5 years. 4.4518. Again, to me, this factor means if I invest today $4.45, I can get $1 out of this investment for 5 years. So I will get a total of $5 out. But I want to get $100,000. So let's take this factor, 4.4518, and we're going to multiply it 4.4518 by future value of annuity. So I have to invest today $445,108, and then next 5 years, every year I will receive $100,000. Like you want to, retire or something. So I will get $500,000 in total, $100,000 every year for 5 years. Now, if the interest rate is higher, if I can find an investment with the higher interest rate, that means that I have to invest less today, right? If the interest is more beneficial to me, then the present value, the original value of my investment will be less. I would have to invest only $399, $270 to get $100,000 every year for 5 years. Couple of other examples. I have Tessa who wants to take the next 6 years of work to travel around the world. She estimates her annual cash needs at $31,000. So she wants an annuity, right, for 6 years, and every year she wants to receive $31,000. Her interest rate is 12%. So how much money does she need now to not work and travel for 6 years? So 6 years, 12%, future value of annuity $31,000. If we look up in the table, 6 years, 12%, the present value of annuity is 4.114. If I go to the table, that's what you find. She wants $31,000 every year. So today she has to invest $127,453. What if she can only earn 8%, right? Instead of 12%, she can invest her money only at 8%. What would be happening with the present value of annuity? Would it be higher or lower? Pause and think. So if the interest goes down, then the amount she has to invest has to go up, right? Because the money is not earning as much as in the first example. She has to invest today $143,310. So for the next 6 years, she can get $31,000 out. And then the last example here, kind of interesting. I'm combining both present value of a dollar and present value of annuity. What if she wants to retire 20 years from now, right? So this is present. She wants to retire. This is future, 20 years. Oops, 20 years. And today is 0, right? Today is that present value. And then she will need $80,000 every year for 25 years. So she's planning she will live for 25 years more after she retires. And she needs an annuity, right? Every year for 25 years, she needs $80,000, $80,000. And she can get 10% on her investments. So I would first do this problem. I would first discount this annuity, right? I would see how much money does she need to have at this point so that she can get 80,000 every year for 25 years. And then I will take this amount and then I will discount it back to the present value as a lump sum. So this is kind of, I think, beyond of what this chapter is talking about, but I think it's an interesting example. So 20 years from now, she will need, and I calculate, right, present value of annuity, table B3. It's 25 years because she wants to have income after she retires for 25 years. She can earn 10%, and she wants to be able to get $80,000 every year for 25 years. So I look up present value of annuity, multiply it by the annual payment. So today, not today, 20 years from now, she must have in her investment $726,160. So at $726,160 at 20 years from now. And then I take 726,160 and discount it to today. So I use table B1. It's 20 years from now, 10%. And this is the present value of $1 factor. So if she invests today $107,907, keeps it in the investment that pays her out 10%, she keeps it for 20 years, then 20 years from now, it will grow out to be 726,160, which will pay her $80,000 every year from that investment for 25 years. And the last typical example is, congratulations, you have won a state lottery. The state lottery offers you the following after-tax payout options. You will get 13.5 million 5 years from now. Or you can get 2 million at the end of each year for the next 6 years. Or you can get 12.5 million 4 years from now. And the interest is 10%. So we have to discount option 1, that's a lump sum. We have to discount option 3, that's a lump sum. And we have to discount option 2, which is an annuity. Right? Again, I'm looking at the factors, so I'm using the financial calculator. And when I look option 1, I can get 13.5 million 5 years from now. So today, what is it worth? Right? This is the present value of annuity factor. Again, how did I find it? Let me go right here. It's 10% 5 years from now. So if I go to present value of $1, 10% 5 years from now, 0.6209. 0.6209. There you go. Multiplied by the future value. So today it's worth 8,382,150. So any kind of business idea or investment always talks about how much should you invest today to get that much in the future. You're trying to open a new business. Well, I have to invest so much today so that a year from now my cash flow will be X, and 2 years from now my option will be Y, and so on and so far. So a year from now I can make $200,000. Well, but it's not worth $200,000 today. So it's going to be worth less. So we have to discount it to the present term, to the present value. Option 2 was a lump sum. I can get $2 million at the end of each year for 6 years. So I use present value of annuity. Look, it's better. The present value is 8.710 million. And option 3, I can get 12.5 million 4 years from now. Present value is $8,537,500. So option 2 is the best option. And that's how we would look at most of the business decisions that involve long term. I hope this lecture was useful to you. And for managerial accounting, I will record a second part of the lecture where I actually will talk about capital budgeting. Thank you so much.